Hey, what's up, interweb? Okay, what we're going to do today is the same thing we did the other day. We're going to solve systems of equations, but this is a different method. This one's actually easier. What in the world? Okay, solve systems of equations by elimination. Now, the first thing you do is write the equations in standard form. If you'll remember, standard form is ax plus by equals c. Okay, c is the constant. It's the number. So really what we're doing is we're solving this equation for c. So if you have, now what we're going to do by elimination is we're going to add the two equations together. So if we have this, if we have x plus y equals 5 and x minus y equals 3, system of equations. Now what we're going to do is we're going to add these two equations together. And when we do, it's going to eliminate one of the variables. X plus x is 2x. And y minus y is 0. It's eliminated. It's gone. And that's what we want. Equals 8. Now we have a real simple algebra problem. Divide by 2, so x is 4. Now we plug this back into either equation. It doesn't make any difference which one. Let's use the top one to get away from these godless negative numbers. So x is 4. So we plug 4 in for x plus y equals 5. Okay? So now we subtract 4 from each side. Y equals 1. So our answer here is, our solution is 4, 1. Remember, this is where the two lines cross. It's the one point that satisfies both solutions. So we plug them back in. 4 for x, 1 for y. 4 plus 1 is 5, so that one works. Now we plug in 4 for x, 1 for y. 4 minus 1 is 3. So remember, it has to work for both of them, not just one. Now, what if we have this? 4 plus y. No, stupid boy. That's not right. I'm sorry. Wasn't paying attention. I'll do better. Y plus 11 equals 2x, and 5x equals y plus 26. Now remember, system of equations. Now remember, we want to write this in standard form. So we want all the x's and the y's on this side and the numbers over here. So let me rewrite this one over here, where y plus 11 equals 2x. Now I'm going to do two steps at once here. I'm going to subtract 11 from each side, and at the same time, we're going to subtract 2x from each side. Okay, so we have negative 2x plus y. Okay, that's gone, that's gone, that's gone, that's gone, equals negative 11. Right? Right. And this one, well, what a rat's nest this is. 5x equals, excuse me, y plus 26. Now, this one's not so bad. We just have to move the y over there. So we subtract y from each side, and we get 5x minus y equals 26. Okay, so we have these two equations. We have negative 2x plus y equals 11, and we have 5x minus y equals 26. Okay? Now this one is the same as that one. It's just rearranged. And this one is the same as that one. Again, just rearranged. But they're exactly the same. So now look, y minus y is 0. It's going to be eliminated, and that's what we want. So we have 5x minus 2x is 3x. That's gone. Equals, what is that, 37? Oh, I'm stupid. Doggone it. What does it matter? Oh, equals negative 11. This is negative 11. Sorry, I'll do better. No, I'm probably not. Okay, so 26 minus 11 is 15, I think. And then we divide by 3, so x is 5. Now we plug this back into any of these equations. It doesn't make any difference. Let's use this top one because it's almost solved for y. Y plus 11 equals 2x. Okay, so we plug x is 5. We plug it into there. So we get y plus 11 equals 2 times 5 is 10. Subtract 11 from each side. Y is negative 1. So we have 5 comma negative 1 is our solution. And you plug them back into the original equations and see if they work. I know this seems kind of complicated right now, but again, the first thing we do is we write the equations in standard form. Okay? Next. Now we have, now they get a little bit more involved in what we just did, but really not very much. 2x minus y equals 12, and 3x plus 2y equals negative 3. System of equations. They are already in excuse me, standard form. So when we add these two equations together, will it eliminate one of the variables? No. This one's negative y, so really what we want is we want the opposite of 2y. And the opposite of 2y is negative 2y. So what can we do to this equation here to get negative 2y? We can multiply it times 2. Will that change the value of this any? No, it'll just change the look of it. And this is, we multiply everything by 2, a distributive property. So we get 4x minus 2y, which is what we want, equals 24. Is that right? 4x minus, excuse me, 2y. Okay, now we bring this one over. We get 3x plus 2y. You can see that these are going to they're going to eliminate each other, equals negative 3. Now we add these two together, these two equations together, and you can see that when we do, that one's going to be eliminated. So we have 7x equals 21, 24 minus 3, 21. Divide by 7, x is 3. Okay, so let us, you can use either one of the equations. It really doesn't make any difference. Let's use the top one, although we're going to have some godless negative number in here. So we have 2x, x is 3, minus y equals 12. 6 minus y equals 12. Subtract 6 from each side. Negative y equals 6. We either divide or multiply, doesn't make any difference which one, by negative 1. So what's going to happen? The signs are going to change. Divide by negative 1, so we get y equals negative 6. So our solution is 3 comma negative 6. And if you plugged it back into these equations, you will find that it works. I hope. Okay, now the one thing that kind of gets confusing here is when you multiply by 2, if you multiply the whole equation by 2 or anything, as far as that goes, the equation looks different, but the values are exactly the same. Oh, sorry. Okay, so what if we have this? X plus 4y equals 16, and 3x plus 5y, 3x plus 5y equals 20. This is a y here. System of equations. Now remember, we want one of these equations. Sometimes you have to do both equations. You have to change both of them sometimes. But this one, we can see that x is a factor of 3x. This is where you want to take a drink. Here's a nice pretty Diet Coke with crushed ice. Mm-hmm. Okay. 4 and 5 are not factors of each other, so let's not change that one. Could if we wanted, but let's not. Let's make this easy. Now, what can we multiply x by to get it to be the opposite of 3x? We can multiply this by negative 3. Negative 3 times x is negative 3x. Negative 3 times 4 is a negative 12y equals negative, what is that, 48? I think so. Now we're going to add these two together. 3x minus 3x is 0, right? Right. And 5y minus 12y is a negative 7y equals a negative, I think, 28. Again, we're adding these two equations together. Divide by negative 7, so we get y equals 4, I think. Let's use the top one, the original one at the top, and that was x plus 4y equals 16. My y's are looking like x's. Excuse me. Okay, so x plus 4 times y, now we know that y is 4, equals 16. So x plus 16 equals 16. Subtract 16 from each side. X equals 0. Can we have x equals 0? You betcha. So our point of intersection where the two lines cross is 0, 4. And if you plug these back into the original equations, you'll find that they do work. Now this next one is about as difficult as these get, and it's really not very difficult. We have this. We have 4x minus 3y equals negative 19. And 3x plus 2y equals 24. System of equations. Is 4 and 3, are they factors of each other? No. Are 3 and 2 factors of each other? No. So we're going to have to change both of these equations. Now this one's already a negative number, and this one's positive. So let's change both of these. Now what's a number that we can multiply by easily where we can eliminate the y's. We can do this one by 2 and this one by 3. If we do this one, we're going to get negative 6y. And when you multiply this one by 3, we get positive 6y. So now we do distributive property, and we get, what is that, 8x minus 6y equals a negative, I think, 38. This one, we're going to multiply by 3, because remember, what we want to do is we want to eliminate these two. We could just as easily have eliminated these, but these numbers are smaller. This one's already negative, so let's use that one. By 3, and we get 9x plus 6y. See, there we go. We eliminated that one. Equals 72. Yeah. Okay. It's a system of equations. Remember, these two they're equal to each other. They just look different. Okay, now we add these two equations together. We get 17x, negative 6y, positive 6y, 0. That's what we wanted. Equals 40. What does it equal? 34? Yeah, I think so. Divide by 17. X equals 2. Now we can plug this 2 into any one of these 4 equations. Let's use the bottom equation here. Let's use this one. So 3x, x is 2. 3 times 2 plus 2y equals 24. And we could just as easily have used these equations over here because they're equal to these. They just look different. So we get 6 plus 2y equals 24. Subtract 6, subtract 6. 2y equals, what is that, 18? I think so. Divide by 2, so y is 9. 2 comma 9. There's our... You can see these problems, and like I said, this is as difficult as this gets. And this only took us just a couple of steps. Well, remember the other ones were where we had substitution would take almost a whole piece of paper. Man, it's cold in here. Hate to be a hater, but I'm hating on cold. Okay. And what if we have this? Get this if you're so smart. 5x minus 2y equals 3. And 10x minus 4y equals 5. System of equations. Okay. Now look, 2 is a factor of 4, but this one's negative and this one's positive. Now we could also multiply this by negative 2 and we get negative 10. So let's multiply this by negative 2 and we get negative 10x minus, plus, stupid boy, 4y equals negative 6. And this one is 10x minus 4y equals 5. Now when we add these together, we get negative 10x plus 10x is 0. 4y minus 4y is 0. And negative 6 and 5 is negative 1. So 0 does not equal negative 1. Therefore, our solution set is the null set. There is no solution to this. If you'll notice these two lines, negative if you'll notice, this one is twice, exactly twice this one. So in other words, it's the same, well, not the same line, but they're parallel lines. Okay. Mm-hmm. Now what if we have this? 5x minus 4y equals 15, and negative 3x plus 6y equals negative 9. System of equations. Okay, these are none of the coefficients are factors of each other. So we're going to have to change both of these. But if you look, this one's negative and this one's positive. So let's change this one. Or let's change the x's. And what can we do to the x's? What do we want this number to be? 15x and negative 15x. Excuse me. Or we could have done this one just as easily, but the numbers would have been larger. So what are we going to multiply this one by? 3. And that equals 15x minus 12y equals, I think, 45. And this one we're going to multiply by 5. And we get negative 15x plus, what is it, 30? 30y equals negative 45, I think. And we're going to add these together. Ergo the name elimination. 15x minus 15x is 0. It's gone. It's eliminated. 30y minus 12y is, was it 18? 18y equals come on, boy, think. 0? I think so. Divide by 18. Y equals 0. Now we plug it into, again, either one of these. Let's use this one. Get rid of this godless negative number here. So we get 5x minus 4 times y is 0, equals 15. Okay, anything times 0 is 0, so this is gone. So we get 5x equals 15, divided by 5, x is 3. So our solution is 3, 0. And it's suggested that you plug both of these in to both equations and see if they work. Well, let's do this one real quick. X is 3, y is 0. 15 minus 0 is 15, so it works. And we, again, 3 and 0. So negative 15 plus 0, negative 5. You're a bonehead. 3 times 3 is 9. All right? Now, negative 9 equals negative 9, so yes, they both work. That's all. Okay, everybody have a good turkey day? Hope so. All right. Y'all be good. See you tonight, hopefully. Bye-bye. Bye, Bonds.